Hey guys, so a few notes I want to add to questions that involve geometric series. My first tip is to always write down every formula. For example, I will say that the general position term un is always a times r to the power n minus 1, where a is the first term and r is the common ratio. We also need to know that the sum of the first n terms, which is a times 1 minus r to the power n, all over 1 minus r. And lastly, we need to know the sum of infinity. So sum of infinite number of terms, which is just a over 1 minus r. And that's it. If you know all of this, then you can pretty much smash every question. So let's have a read. So according to 1, a geometric series has first term a and common ratio r equals 3/4. So effectively you can simplify a lot of these. The sum of the first 4 terms of the series is 175. So this means the value of S4 is 175. So that will be useful for this Sn equation. Show that a equals 64. Well, this is quite easy actually. All you literally do is just plug in the value r here and plug in the value n, which is 4. Replace S4 with 175 and boom, solve for a. So therefore we're going to have, so we can say for S4 we have 175, and this is also equal to the equation up here, which is a times 1 minus r, which is 3/4, to the power n, which is 4 because it's the fourth term, over 1 minus 3/4. And now all you do is just isolate this. So to make your life easy, I mean, you could go ahead and solve this, but I would just divide it all across. So I don't and make a the subject. So making a the subject, we're effectively going to have 175 over everything you see here, which is 1 minus 3/4 to the power 4, all over 1 minus 3/4. So make sure you put all of this in the calculator exactly as you see it. And if you do it, you should get an exact answer of 64. That's it. You don't necessarily need to show everything. This is enough, and you can just input this in your calculator, and that's it. Right. Easy, literally as easy as that. Now, part B. Find the sum to infinity of the series. Well, the sum to infinity is just a over 1 minus r. So plug in the value a, which is 64. Plug in the value r, which is 3/4. Smash this your calculator, and you should get an exact answer of 256. Done. So easy, really. Now, C. Find the difference between the 9th and the 10th terms of the series. Okay, so find the 9th and 10th terms. Give your answers to 3 decimal place. Well, you could write this in any order. You just have to find practically un, or u10 minus un, or u9 minus u10, or u10 minus u9. Just the difference between them. So whatever the difference is, make sure the final result is positive. If you get negative, just make it positive, because that's the actual total difference. So here, so for part C, we can just say u10 minus u9 doesn't make a difference. The value of u10 using the general formula is a r to the power n minus 1. So it's going to be a, which is in the first term, which we found out was 64, times r, which is 3/4, to the power of n minus 1, which is 10 minus 1, which is 9. And all of this minus the same thing, but to the power of 8. And well, when you do this, you're pretty much done. The answer should be, well, in my case, it looks like I'm going to get a negative answer. You should get minus 1.602. If you did it the other way around, you get a positive answer. But either way, you would say in words, the difference between them is 1.602. And that's it, guys. That should wrap you up with 4 marks. Okay, guys, question 2. So the curve C has the given equation, which is y equals 8 minus 2 to the power of x minus 1. And we're taking values between 0 and 4 for x. Now, according to part A, we just need to complete a table and by plugging in the value of x equals 1. And well, that's obviously easy. Plugging in the value x equals 1 in calculator, it should look a bit like this. So 8 minus 2 to the power of 1 minus 1. And well, when you do that, you should actually get a final result of, let's see, 1 minus 1 is 0, 2 to the power of 0 is 1, 8 take away 1 is 7. So, now part B, let's see. Okay. So, use the trapezium rule with all the values of y in the complete table to find an approximate value for the integral of this. Okay, so of course we can't integrate directly, so we have to use the trapezium rule. Now, the trapezium rule, thankfully, is very straightforward. Let's have a look. So, trapezium rule is always going to be, firstly, so we just say this is approximately equal to h over 2. So now we're using trapezium rule times the last 2 terms, which is 7.5 and 0. So it's always the last 2 terms. plus 2 times every other term in the middle, which is 7 plus 6 plus 4. That's it. Where, and of course, h represents the width, or well, the height. In this case, it's the tiny little gaps between it if we divided it equally. In this case, we know the gaps between every single one is 1. So h would be, in this case, 1. And yeah, that's it. So now all you do literally is just plug it in and see what values you get. And well, plug it in, you should get exactly, let's see, so 1 over 2 times this, you should get about 20. Oh, but that's not 20, that's a 0. 20.75. And you could say unit squared, but 20.75 is cool. So let's have a look. So we're given a figure which shows this equation. Yep, that's clear. And if we just look at it for a second, yeah, every time they give you an equation and they ask you to find the area underneath the curve, it's actually the entire area below the curve. So effectively, it's every single part until it hits the x-axis. So if you want to find just this little region, we just have to realize that firstly there's a straight line here, and this one kind of looks like a right angle triangle, the white region. So if you integrate this, well, we already did, we got about 20.75 using the trapezium. All we need to do is find the area of this triangle and subtract it from this bit to get the region R. Now, how do we do it? Well, this information will just tell you literally what I just told you. So we can say firstly at the point A, which is of course the furthest point, and in this case the furthest x value is clearly 4, and that gives you a y value of 0, so 0 and 4. This would mean that this corner here is going to be 4, 0, so this will be effectively 4. So we know that the width is now 4. For the height at B, this is when x is 0, meaning y is 7.5. So now the height here is 7.5. That's it. Now to find the area of a triangle, it's just base times height over 2. So you just put 4 times 7.5 over 2, and that should give you 2 times 7.5, which is 15. And then just subtract it from 20.75 and you're left to the region R. So 20.75 minus this will give us exactly 5.75. That's it. Easy. Okay, number 3. So what do we have? So, it's corner geometry. So just before we read this, just have a quick look. We have P, which is probably the center of the circle, Q, which is actually a tangent of the circle, meaning that there's going to be probably a straight line here which we need to work out. And this will tell us that the gradient here is going to be perpendicular. So if we have to find the gradient of this line, well, this line will be the perpendicular gradient. So we need to flip it. Anyway, let's have a go. So the circle C has a center P, which is 7, 8, so keep that in mind. And pass through the point Q over here, which is 10, 13, as shown in figure 2. Now, find the length PQ. Okay guys, this is straightforward. This is just the distance formula. So the distance here, in other words, actually the distance is also the radius. So the radius, we just use Pythagoras. So we just find the difference between the x and square them plus the difference of the y's. So the difference between the x is 10 minus 7, which is 3, so it's 3 squared, plus the difference between the y's, 30 minus 8 is 5, so it'll be 5 squared. And 3 squared plus 5 squared, and square rooting it will give us root 34, so root 34. That's the distance. We're done. Now, let's have a look. Next one, B. Hence, write down an equation for C. Well, the general equation for a circle is always x minus a squared, so let's write down. So x minus a squared plus y minus b squared equals r squared. The reason why it's like this is because this is the typical circle equation where a and b are the center of the circle, i.e. point P, and r is just the radius, which we already found. So given that we know the center circle, which is 7, 8, well, we just literally write down. So it'll be x minus 7, which is that point P, which is the center, and squared plus the y value, which is 8. So y minus 8 squared, and all of this must equal r squared. Since r is root 34, that means r squared is just 34 without the root. Yeah, not bad. Very easy. Now, next one. The line L is a tangent to C at the point Q. So again, everything we already know. So find equation for L in this form. Okay, so just a long story short, I would always find the gradient first. So this is typical. Find the gradient of this line and then realize that this line is perpendicular. And we can always find the gradient when you have 2 points. So to find the gradient of the line PQ, so let's call it line PQ, the gradient would just be the change in y over the change in x. And yeah, change in y between p and q, so let's have a look. It's going to be 13 take away 8, which is 5. And then change in x would be 10 take away 7, which is 3. So the gradient for the line PQ is 5 over 3. Now, given that the line L is perpendicular, this means we just have to flip this upside down and stick a negative sign. So for the line L, then the new gradient is going to be the perpendicular gradient of this one. So it'll be flip upside down, so you get 3/5, and change the sign, so it'll be negative. Now, let's write this what we know. So going to part C, we can firstly say that the general equation for a line is always y equals mx plus c, where m is the gradient, c is the y-intercept. M we just found, which is minus 3/5. Trust me guys, this is dead easy, yeah? Minus 3/5 x plus c. Now all we need to do is just pick any coordinate on this line that we know, and for example we know q is on this line, plug it in and find the value c. Then rewrite the equation with c and voila, done. So let's just say at the point PQ, so at PQ, the equation now becomes, so at Q we have coordinates 10, 13. So x is 10, y is 13. So the equation becomes 13 equals minus 3/5 times 10 plus c. Solving this one, 13 equals minus 3/5 times 10. So that gives you minus 6 plus c. Eventually you'll realize that the value c should now become, so adding 6, 13 plus 6 should be 19. Yeah, not bad. So since it's 19, now you just plug it back in, so you can have the new equation, which is going to become y equals minus 3/5 x plus 19. Voila. Now just to make sure we're done, let's have a look at the equation. So give your answer in the form ax plus by plus c, where each of them are integers. In other words, clear the fraction, yeah? So what I would do, I would multiply 5 across here. So let me just do it, change the color so I can see it clear. So change the color, so times this by 5, you're just going to get literally 5y equals minus 3x plus 19 times 5, which is 95. And then just throw everything to the left hand side. So it's going to be, let's see, throw everything to the left hand side. So throw 3x across the 95 and you should get 3x plus 5y minus 5y minus 95 equals 0. And that's it. Case closed. If you guys got this, seriously, give yourself a pat in the back. Otherwise, let's move on. Question 4. Okay, this question is actually very straightforward. It's just the remainder theorem, the factor theorem, and then, of course, good old long division, which nobody really likes. So, let's check it out. So, so use the remainder theorem to find the remainder when fx is divided by 2x plus 3. Now, effectively, the remainder theorem means you just literally find the value of x here, which is, if you solve it, you're going to get exactly minus 3 over 2. If you're not sure how we get that, well, just let 2x plus 3 equals 0, rearrange it, and you get this. Now, all you do is plug this into this equation and see what the remainder is. So let's do it. So we say at the value of minus 3 over 2, the equation therefore becomes, so plug in carefully. So just if you're not sure, always plug in like this. Whip a bracket here so you avoid like little errors. It's bracket squared minus 4. Doing that, I believe you should get an answer of 5. That's it. So therefore you'll say that the remainder of this value is, well, 5. Oops. Okay. Next one, part B, yeah? So use the factor theorem to show that x plus 2 is a factor of fx. So in this case, to show if something is a factor, this implies that there should be no remainder. Okay, in other words, letting x plus 2 equals 0, we can pretty much use the value of x equals minus 2 if you solve it. So B. So again, B is just like A. Plug in the value of minus 2 into this equation, same style, and to prove that it's a factor, well, your final solution in your calculus should be 0. No remainder. So no remainder implies that this term can be used to factorize this expression. So it's a factor. So x plus 2 is a factor. Thankfully, these questions usually tell you what to do, so that's cool. Now, C is quite obvious. we need to factorize fx completely. So you could use long division, totally up to you. So I'm going to go ahead and use long division. Okay, so let's do this. So let's see, x plus 2 into that. So this is just going to take a while. So let's quickly write it down. So we go x plus 2 times the entire term, which is 6x cubed plus 13x squared. 6x cubed plus 13x squared. And minus 4. So notice that there's no x term. So we just say plus 0x. Just to occupy the space here. Minus 4. Alright, that's it. Now, all we have to do, so to begin this equation, always ask yourself, so how many times does x fit into 6x cubed? Well, this fits in exactly 6x squared times. Another way to just think of it is just divide the terms. And you should get 6x squared. That's another way to look at it. Now, all you do is just multiply this by the factor. So 6x squared times the bracket should give us 6x cubed plus 12x squared. Now, what is the point is, we're trying to basically keep on doing this until we get a final remainder of 0. And then the top half, the quotient bit, would be the part we can factorize. Now, anyway, let's subtract this, yeah? So big bracket, a minus sign. All of this should just give you single x squared. Drop the 0x, so plus 0x, and repeat the process. Now, ask yourself, how many times does x fit into x squared? Well, it fits in exactly x times. Again, do the same idea. X squared divided by x is x. Now multiply x by the factor and you should get x squared plus 2x. God, that's ugly. 2x. Oops. 2x. And now subtract it again. So big bracket minus this. So you should get 0 minus 2, which is minus 2x. And lastly, drop the negative 4 down. So you get minus 2x minus 4. Ask yourself, how many times does x fit into minus 2x? It fits in exactly minus 2 times. Multiply minus 2 with the factor and voila, you should get identical expression, which is minus 2x minus 4. And again, this will give you no remainder. And that's it, guys, you did it. So now you can effectively say that when x plus 2 is multiplied to the quotient bit, the quadratic bit, you should get the cubic fx value, fx expression. So now, final step is to fully factorize. We need to also factorize the quotient bit here, the quadratic bit. So let's write down the full bits that we're at so far. So we've got x plus 2 times 6x squared plus x minus 2. Now this one's obviously a bit more annoying. So it just comes with trial and error. So I'm just going to go ahead and go on a limb here and just assume it could either be 6x and x when you the two brackets or 2x and 3x. I'm going to try 2x and 3x first. My tip for these ones is to just use trial and error, honestly, because it's a lot better than thinking too hard about it. Now, where are we? So what we could do here is also what two numbers multiply to make a 2? Well, that's easy. It's just going to be 1 and 2. Now the question is where we're going to put it. So let's just go ahead and put 1 here for a second and 2 there. If we multiply 2x by 2, we're going to get 4x. 1 times 3x is a 3x. So, yes, well, fortunately this is correct. We just test like this. So 4x, so to get plus x, it would be 4x minus 3x. So it would just be, in this case, a positive and a negative. So to get 4x, it would be positive here and negative there. Number 5. Well, you know, a paper is always good when you have a binomial expansion bang in the middle, because this is going to be a lot of easy marks for these kind of questions. So what do we have here, guys? So A, find the first 3 terms in ascending powers of x of this binomial expansion. Well, there's 2 ways of doing this. You could use the general, the NCR method, which is probably what a lot of you guys are using. However, if you're taking this all the way to C4, I would recommend you use the C4 method, so you have one formula to work with. So I'm going to go ahead and expand this here. So 2 minus 9x to the power 4. The tip is to rewrite this in terms of 1 plus ax, so to get the 1 here. Now to do this, we need to factorize 2 out. So we're going to rewrite this as 2 to the power 4 when you factorize it out, times, now when you factorize 2, you get 1 minus 9 over 2x, all to the power 4. Now this, my friends, is what we're going to actually expand. Okay, let's do it. So expanding this, take 2 to the power 4 outside. Expanding this one using the general term, it's going to be, and you should follow this carefully, it'll be the first term 1 plus, and it's going to be the power multiplied by the term here. So it'll be 4 times minus 9 over 2x. And now the next one is going to be all in descending order, yeah, of powers. So we're going to do the power times 1 less the power, so it'll be 4 times 3 over 2 factorial, because it's 2 terms. And then we copy the term and we square it now. Minus 9 over 2x to the power 2. And that's it. And if you have to do a third term or you repeat the process, it'll be 432 over 3 factorial, powers 3, and so on. Anyway, that's it. So now all we do is just expand this and tidy up. So let's have a look. So all we do now, so first things, do one term at a time. So for the first term, it'll be 2 to the power 4 times 1, which is going to be 16. If you guys need help with this, it's quite straightforward. Just do 2 to the power 4 times minus 9 over 2 in your calculator, and you should get exactly minus 288. Pop in an x. And for this bit, in your calculator, write 2 to the power 4 times this entire fraction times 9 minus 9 over 2 all squared, without the x obviously. And doing that will give us exactly plus 1944x squared. Easy stuff, easy stuff. Now, here comes the main event. So let's check it out. So according to this one, fx equals 1 plus kx, one linear term, times what we just had up here. So this would effectively be the expansion here. Okay. The expansion is in ascending powers of x of fx up to and including the term in x squared is this. So in other words, expanding this up to x squared will give us this kind of result. Now you have to find the values of a, b, and k. So effectively we're going to do 3 parts in one. So let's do it. Let's go ahead and expand this term up to and until x squared. So to do this fast, I'm just going to rewrite this one as all of this times 1 plus kx. Okay, now let's do it. So let's multiply all of this firstly by 1, which, well, will give you the same result. It will give you 16 minus 288x plus 1944x squared. Next, we're going to multiply by kx, and we're only going to stop after it reaches x squared. Okay, so times all this by kx, you're going to get first, which is 16kx minus 288kx squared plus, and that's it. Next one will give you a cubic answer. Now what do we do here? Well, now we just match coefficients to each term. For example, we can say firstly that for the first term, the constant term a must be equivalent to 16 because they're the only constants here. So we can say a is 16. The next bit, in terms of x's, we can say that minus 232x is equivalent to minus 288x and 16kx. So writing it as an equation, we could say minus 232, in terms of x's that is, yeah, is equivalent to minus 288 plus 16k. So minus 288 plus 16k. And now you just have to solve this and make k the subject. So doing this and making k the subject, you should basically get 7 over 2. So just plus 288 and then divide by 16. And lastly, the final term, so for bx squared, guys, we have to make bx squared equivalent to 1944 x squared minus 288k. So let's write it down here. So 1944 minus 288k must be equivalent to b. And this is easy. We know that the value of k is literally 7 over 2. Plug in 7 over 2 here, and you should get 936. That's it. Done. We'll be trying to solve this trig equation within this interval. And to do it, all we need to do is make cos the subject and cos inverse. So let's do this. Let's make 2 cos this time the subject. So we're going to have 2 cos theta minus pi over 5 equals to 1, and then it's divided by 2. So we're going to be left with cos theta minus pi over 5 equals a half. Now cos inverse in this, we should get this. Cos inverse of half will give us pi over 3, in the calculator. So remember, this is the cos inverse. Now, notice that we have this term, pi minus pi over 5, and this is the interval we have. So all we really need to do is rewrite this interval with pi theta minus pi over 5. So therefore, within the interval of theta minus pi over 5, we should subtract these two amounts. So we're going to have pi, take away pi over 5 will give us 4 over 5 pi, minus pi over 5 will give us minus 6 pi over 5. And this is the interval we are now working with. So to do this, we always start with the cos diagram. So if you recall, using the cos diagram, we only deal with quadrants that is related to the function we're using. So because we're using cos, we use C. And because A indicates all, we always start from here. So we have an angle here which is worth pi over 3, and an angle here which is worth pi over 3. Now, let's have a crack at this. So all we're really doing is pretty much traveling up 1, pi over 3, which we have, and the second one we just go down pi over 3 as well. So remember, this is 0. So if we go backwards, we subtract. So our second solution would be negative pi over 3 because we went back. And that's it. Because the interval is so small, we can only travel pretty much up to here. Adding, going back pi over 5 is pretty much negligible because it's nothing. Same here, you're only going to travel up to here. You can't go any more further. So hence, these are our solutions. So now, to get the actual value theta, we just add pi over 5 to both these terms. So therefore, theta equals pi over 3 plus pi over 5. And theta also equals minus pi over 3 plus pi over 5. And that's it. And what do these both give you? Well, the first one is going to give you 8 pi over 15. Yep, and the second one, minus pi over 3 plus pi over 5, should give us minus 2 pi over 15. Here we'll be looking to attempt to solve this trigonometric equation using this interval. Now, the first thing I want you guys to notice is firstly this expression. So this is pretty much a typical one. Any equation that involves sine and cos, the whole purpose is to rearrange them back to either sine or cos. And the smart thing to do is to just consider some identities. First, I would have a look at this one. Why? Because we should know that cos squared is actually part of the typical sine squared x plus cos squared x equals 1 identity. Notice that we can rearrange this one to make cos x squared the subject. So hence, subtracting sine squared x, we should have this. And there we go guys. Pretty much putting this back in, we have an equation in terms of sine. So let's have a shot at this. Okay, so I'm going to write from here. So replacing cos squared x, we should have 1 minus sine squared x here, plus 7 sine x minus 2 equals 0. Of course, expanding this and simplifying, so I'm just going to expand this quickly. We should get all of this. So if you guys already know this and doing it, I would suggest, trying attempting this yourself. So now here we got collecting terms. We got 4 take away 2 is 2. And putting everything on the other side to make this term positive, we should have 4 sine squared x minus 7 sine x minus 2. Again, I just threw everything onto the right hand side. Now here we are, a typical quadratic equation. What do we do? Well, the best thing to do now is to simply factorize. So let's have a try. So I would say firstly, let sine x equal y so we can see it clearly. So we're going to have, of course, 4y squared minus 7y minus 2 equals 0. So factorizing this, what do we have? First we have 4y here, we have a y there, send this to 0. We just need to think. Of course we have 2, so 2 is a prime number, so we can only use 2 times 1 to get 2. Because we have a 4 here, we can say 4 times 2 is 8, subtracting 1 will give us 7. So putting a 2 here would be logical. 4 times 2 is 8 and 1. To make it negative, we should have a minus 8. Okay, so hence, what does it give us? So this means we should have y equals minus a quarter or y equals 2. And of course, y equals 2 can't be a solution because in a typical sin x graph, just for logical purposes, we know the maximum value is 1 and the bottom half is -1. And if we drew the curve, you can see it will never reach it, no matter how many hoops we go through. So yeah, that's something to point out. If you get big numbers that's outside of the 1 and -1 range for either sin x or cos x, it means you cannot use them. Okay, so let's get back to the problem at hand here then, yeah? So let me just quickly erase this part. Okay. Just bear with me, guys. So now let's replace y with sin x again and get back to the question. So what do we have here? So now substituting back in, you got sin x equals -1/4. Taking the inverse of this, so the sine inverse, you guys should actually get an S. Oh, okay, not really good answer. So remember, keep in degrees format, yeah? You should have -14 degrees, 14.5 to 1 decimal place. Now let's apply the cos rule, because that's pretty much the point of this video. Okay. Usually we always check this part to determine how to use it. Notice that we have a negative sign here. This means that we do not put angles in the sine part or the or part. All implies that it's positive. If the equation was, for example, sine x equals 1/4 positive quarter, it means that we would use values from a and s. Because we have negative quarter means we will have to work in the non-sine and all. So this means, let's pop out some angles here. So we got an angle of -14.5. It means that we'll be over here at 14.5 degrees. We'll also be at tan y, because we're not going to be at S or A. We're going to work with T and C. Remember I told you, if this was plus, we work here, negative, we work down here. So now all we do is follow this rule. So here we want to be between 0 and 360. We just have to spin it around. So from here, we go all the way around here. Hold on. From here, we travel all the way here. So this is just simply 180 plus 14.5. So let me just write down here. So one of our solution would be 180 plus 14.5. And then once again, our second solution would be going all the way around and hitting here, which is of course a full turn, about 360, about 14.5 back. So that's 360 minus 14.5. Okay, number 7, guys. Let's check it out. So it looks like we have a curve here and an area underneath it. So this is probably integration. So figure 3 shows a sketch of part of a curve with this equation here. The finite region S, which is bounded between 2 points, 0 and whatever this corner here, which we probably need to find out, is shown in figure 3. Find, okay, A, the integral of this. Alright, so this is just standard integration. Well, we can just do it here. To integrate, you just raise the power by 1 and divide it by itself. So for example, this is going to be 3x squared power 2 over 2 minus x, and then raise the power 3 over 2 by 1, so add 1 to it, so you should get 5 over 2. You could use decimal 2.5 if you like, over 5 over 2. And that's it. Now, because you're integrating and there's no limits, we must always add plus c. And you're done. I mean, just to make it a bit nicer looking, and because I'm guessing we're going to use the result in part B, I would probably just convert this to a decimal or something, just to make it easy. So the first one, 3 over 2, we can just say is 1.5x squared minus, bring this to the top line, so it'll be 2 on top, so it'll be 2/5, which is 0.4x to the power 5 over 2. Just say 2.5, yeah, plus c. Both is correct, doesn't make a difference. Okay, part B. Find the area of S. Alright, let's do it. So to find the area S, we need to first see when the curve intersects with the x-axis. So when it does, this means that the curve intersects when the y coordinate is 0. So it looks like we're going to do a bit of math here first to find the limit. So let's solve the curve equation when y is 0. So effectively, this equation is equal to 0. So 3x minus x to the power 3 over 2 is 0. Now what do we do here? So we could firstly just, factorize x out, which I think is easy. So factorizing x, you left with 3 inside minus. So this is like 1.5. If you take away an x, you take away one of it, so you're left with 0.5. So you have x to the power of 0.5, or half, equals 0. Now this means two things. This means that we have firstly one coordinate, means when x is 0. We also have this term when it's 0. So we're going to use the middle term because x0 is clearly over here, the origin. So the second term, 3 minus x to the power 0.5 is 0. Let's do it, yeah? Let's work it out. So solving this one, I'm going to put it down here. We have 3 equals x to the power 0.5. And to solve this one, we'll just find the 0.5 root. So in your calculator, just write the root of 0.5. Or square it. Either way, you get 9. Okay. And the reason why I write like this is because it's just to make it easy and consistent in case the number was negative. So you can always root it. Doesn't matter what it is. Okay, so this means now the x coordinate is 9 here. So all we have to do, guys, is just integrate from 0 to 9 of this equation. And since we already integrated over here, we can just find the area of B. Part B. So part B is S. So we can say S now equals the region S equals the integral from 0 to 9 of the curve, which we already know. And we've already solved that actually. And yeah, since we already solved it, we got this solution here. The only difference is now is that we have limits from 0 to 9. So instead of having plus C, we will need to substitute 9 first and then 0. So we're going to pretty much work this out. X to the power 2.5 between 0 and 9. Yeah, that's it. So I guess we can chill here. So first things first, you plug in the value of 9. If you plug in the value of 9 into this equation, so yeah, tip, if you guys never done this before, when you substitute the value, when you have numbers like this, you always substitute one number first, the upper value, like 9, and then you substitute the lower value 0, and then you subtract them. So plug in 9 first, you would get 243 over 10 in your calculator, and then substitute the value of 0, you will get 0. So then you would write it like that. The value at 9 minus the value at 0. And of course, this will give us 24.3 or 20 or that over 10. Okay, let's look at 8i now. So given that we got this log equation here, express b in terms of a. So this is quite okay. If you're not sure about logs, the key idea is that when you're subtracting logs with the same basis like 3 here, it means we can divide the insides. For example, we can just say that log, let's say 3a minus log base 3b is the same as log a over b, literally. So now we just divide these two. So we can say therefore these two here is going to become log 3 big bracket 3b plus 1 over a minus 2, and all that's equal to -1. Now the cool thing here is, like adding, subtracting, or inverse operations, we can effectively remove the logs by taking exponentials on both sides. To do that, all we have to do is firstly keep these values, this base value here, so 3b plus 1 fixed over a minus 2, and literally raise this using the stepping method. That is, bring 3 up and then -1 up as well. So all this is going to equal 3 to the power -1. So this is just going up the ladder. So the way this works, you bring this up and that goes up. Yeah, that's how you clear the logs. Now you just solve. Now you just make b the subject. So 3 to -1 is 1/3, so we can just update that. Let me just update it actually. So this is going to be 1 over 3. Now you just cross multiply. So I'm going to multiply 3 across and a minus 2 to the other side. So we're going to have 3 times 3b plus 1 equals 1 times a minus 2. So now expanding the bracket, we're going to get 9b plus 3 equals a minus 2. Subtracting 3 across, you get 9b equals a minus 5. And that's it, guys. B is going to equal a minus 5 divided by 9. Very easy question. Very easy. Okay, part 2 for question 8. Now, this one, again, just like logarithms, is quite straightforward. You just have to be able to break it down when you first look at it. So, to solve this, just notice one thing. This is actually a quadratic equation. How do we know? Well, let's work with 2 to the power x. Let's just say for the sake of it, y equal 2 to the power x. This means if we're gonna just look at the first term, 2 to the power 2x plus 5, we can partition this as 2 to the power 2x times 2 to the power 5. Okay, and of course copy the rest out. So when you, again, just a quick rule, when you're timesing two terms with the same base like 2, you add the powers. So we can actually, of course, split them up and write it like that. Now, going back to the y statement, if I said let y equal 2 to the power x, this means if I was to square y squared would be 2 to the power 2x, which is actually the same as the one over here. Yeah, and that's it. Now all we do is just plug it back in, evaluate this quadratic, and we're done. So what do we have? So we're going to now have, firstly, y squared times 2 to the power 5. 2 to the power 5 is actually 32, so it's going to be 32y squared minus 7 times y equals 0. Oh, and we're done. So now let's see. Let's factorize y out of here. So we're going to have y bracket 32y minus, oh my god, that's weird way of writing. 32y minus 7 equals 0. So the first solution is going to be y equals 0. In other words, 2 to the power x equals 0. And the second solution is, it's going to be 32y minus 7 equals 0. Solving that, get y equals 7 over 32. In other words, 2 to the power x equals 7 over 32. How do we solve this now? Well, you could use two things. You could use log functions, natural logs. It doesn't matter. For the first solution, however, you cannot solve it. Why? Because the log of 0 doesn't exist. So there is no solution. So instantly we can just cross out this one here, and you can check on your calculator. Now to solve the second one, 2 to the power x equals 7 over 32. Just log both sides. So just say, okay, log of 2 to the power x must equal the log of 7 over 32. Okay, and you have to give your answer two decimal places. And thanks to the log rules, we can of course bring the power in front. So it's going to be x times log 2 equals log 7 over 32. And now we just divide log 2 across. So then the final answer is going to be x equals log 7 over 32 over log 2. So go ahead and just put this in your calculator, guys, and I actually need to do the same myself. And doing that, you should get 732 over log 2. Ooh, so I got negative answer here. So I got x equals negative 2.19. That's it. All done. Alright, yo guys, welcome back. So in this video we'll be looking at differentiation, and this time we're giving an enclosure which is over here, and according to this information it says the enclosure ABCDEA as shown in this figure consists of a rectangle. So we've got a rectangle of length y, and this length here of course we can deduce consists of a rectangle joined to an equilateral triangle. So this equilateral, we know this, hence we've got 60 degrees on each side. All angles are the same and the lengths are the same. We have a sector FEA which is over here. So this is 160, this would be 120 degrees. With radius x meters and center f. So the length radius is x, meaning this length is also x. Hence the whole length is 2x. The points B, F, and E lie on a straight line with FE equals x. Okay. Find the meters squared, the exact area of the sector FEA. Oh, so this is quite easy. So if we've got 120 degrees, so the exact area of the sector is simply, you take the fraction of a circle, so 120 over 360 times the area of a circle, pi r squared. And the radius is x, so pi x squared. This value here is just simply a third. So the answer would just be pi x squared over 3. Okay, alright, that's A done. A was easy. Now for part B, given that BC equals y meters, we know that, established, and the area of the enclosure is 100 meters squared. Okay, so the area equals 1,000 meters. Show that you can get this expression. Well, I think this is quite straightforward. So let's have a crack at this, guys. So to find the area, we simply need to find area of each different shape and sum them up. So the area of the rectangle is easy, so go base times height, so 2x times y is just 2xy for the rectangle, plus area of the sector we found out was pi x squared over 3, plus area of an equilateral triangle is just simply a half base times height. So, or we can do the half AB rule. So we take two sides, take the angle between, so half AB sine 60. So half x times x squared sine 60. And sine 60 is actually root 3 over 2, so we can take a note there. And we know and also record that the whole area equals 1,000, so all of this equals 1,000. Now all we do is just simply rearrange and get the answer. So by making y the subject, we want to subtract all of this across and then divide by 2x. So y equals 1,000 minus all of these terms. So minus, minus, what do we have? Pi x squared over 3 minus, so yeah, let's simplify this part. So we got half times root 3 over 2 would be root 3 over 4 x squared, good, and divide it all by 2x. Therefore, simplifying each term, 1,000 over 2x is 500 over x, minus, simplifying this, we're going to have pi x squared over, so the x's cancel out, so this x goes and this x squared goes, so we're left with pi x over 6 minus, and again same thing, we're going to get root 3, we cancel 1x, root 3 x over 6. And notice that they factorize in this format. So what we could do, multiply up and down by 4, so we get 4, and then times this by 4 to get 4 pi over 24. And on the right side, we need to get 3 root 3. To get 3 root 3, multiply up and down by 3. Or is it? Let's have a look. Oops, this should have been 8. 4 times 2 is 8. So multiply up and down by 3. Kind of lucky we had that. So hence, we should get the desired equation, which is y equals 500 over x minus, and this becomes 4 pi x over 24 minus 3 root 3 over 24. And hence, factorizing this like they did will give you exactly what they wanted. Over 24, 4 pi plus 3 root 3. Voila. So not so terrible, but it's just a case of knowing your algebra. Okay, so we're done for this part. Let's move on. Okay guys, here we go. Part C. So it tells us that hence, show that the perimeter of p meters of the enclosure is given by p equals 1,000 over x plus the term you see right here. Now, how do we get now? Perimeter is quite easy. We just look at the shape here and pretty much stack the values. So let's go from the top. So knowing what we know that this length is y as given. This is 2x. We have another y here. Now we have an arc length, and we know that this length is x. So knowing that this is the arc length, we know that the angle here is 120 degrees. To calculate the arc length, quite straightforward. It's simply the circumference times, it's a fraction of the circumference more or less, and a fraction of circumference here is 120 degrees over 360 times the circumference, which is 2 pi or 2 pi x. And remember, this was a third, so therefore the circumference, the arc length is just 2/3 pi x. Easy. So this is 2 over 3 pi x. Cool. Now just add them all up. So therefore, p equals what did I say? P equals. Oh yeah. So p equals. So adding up the y's, we got 2y plus we got 3 lots of x's plus 2 over 3 pi x. And in this case, notice that this equation, the p equation here, has no y, so we just replace y with our equation we previously found, and thus we should have p p equals 2 multiplied by replacing y 500 over x. So this is going to be one long ass equation. Oh crap. Minus x over 24 times 4 pi plus 3 root 3 close bracket plus these last two guys plus 3x plus 2/3 pi x. Okay, let's summarize this. So notice that they just did some quick maths here. So this became over 12. So in other words, we'll end up getting a 2x here. The rest of the terms inside are more or less the same. Okay. Well, all we can do is pretty much expand this. So let's expand this all one time. Okay. So inside here, well, we're gonna ignore this part. So expand the square bracket part. Let me change the square bracket not to mix this up. So we get 2 times 500 over x, so we get 1000 over x minus 2 times these guys, 2x over 24. Copy the rest plus 3x plus 2/3 pi x. Okay, so they probably want us to expand the right hand side. So let's just focus on this part now, yeah, and try and lock in the same bracket. So we're gonna have 1000 over x minus, let me multiply this out. So we're gonna have 8 pi over 24x plus 6 root 3x over 24 plus 3x plus 2/3 pi x. Collecting everything, notice I all have in terms of x. What do we have in common? So we got 8 over 24 plus 2/3 pi x. So you put that in the calculator or collecting terms, you should get, and also collect terms here. We should also have, yeah, so this and this will give us pi over 3. This term and, yep, so this term and also this term, adding them up, so what do you get? So 6 over 24, simplifying this is a quarter. So we're going to get plus a quarter root 3 plus 3 bracket x. I should also add an x here as well. And then we put 1000 of x minus all of this. And can we get it? Yes, we can. I believe we can. So let's try this out. So therefore we got 1000 over x. And this question, they really have to make it long, equals plus pi over 3x. And now we just have to expand these terms. Plus root 3 over 4x plus 3x, and I can do this all in one go. Okay, so I just open up a fresh page because I've pretty much run out of space here. So what do we have? So let's continue where we left off. So our perimeter now is given by this from the previous one. We want to try and put into this format. So the left side is fine. What we could do is put all of this over 12. That's the first thing. So made this entire fraction over 12. So we're going to have 1000 over x plus multiply this term here up and down by 4 will give us 4 pi over 3 over 12x plus multiply this term here by 3 up and down, so we have 3 root 3 over 12x plus this term here up and down by 4, we're going to have 12x over 4. Yeah, just making sure this is, oops, 12x, no, we're going to multiply by 12 obviously, so it'll be 3 times, yep, and then times again by another 4. You know what I mean, guys. Multiply up and down here by 12, so we're going to have 36x over 12. Oh, damn, what's with this speed? Yep, and that's it. Now we just factorize all this, guys. So therefore, at long last, we have 1000 over x plus x over 12, factorize x over 12 in all of them, and we're left with 4 pi here. We're left with plus 3, this should have been a negative sign. We're left with minus 3 root 3 over 12, but I'm going to put in their order, just for the sake of completing this question. Okay, voila, done. So now let's just move on to part D now, yeah? This was a long question. Alright, so part D now, at last, that question was hell part C. So here, it tells us to use calculus, i.e. to differentiate, to find the minimum value of P, giving the answer to the nearest mediator. So in the purpose of this question, we will need to differentiate this equation and solve it and set the equation to 0 and find the value of x. For that value of x, we're going to assume that it's minimum, and of course to prove it, we need to do part E for that. Find the value of x, substitute in this equation, and find the value of p, which will give us the minimum value of p. So here we go. So finding dp over dx, the first derivative. Of course, before that, it's best we rewrite this top equation into the standard format. So here we should have p equals 1000 x minus 1 plus, and the rest of the terms are actually fine. Okay, that's enough. So let's have a go. So differentiate x 1000 x minus 1, draw the power minus, we're going to have minus 1000 x to the negative 2. Now differentiate the right hand side here, you just treat the rest of these terms as constant. So you're left with plus 4 pi plus, oh no, my pen, plus 36 minus 3 root 3 over 12. X just vanishes. We set this equation to 0 and plus 1000 across, so we're going to be left with 4 pi plus 36 minus 3 root 3 over 12 equals 1000, and we can change it back to the standard format, over 1000x squared. Throwing this all in the calculator, we should have x and times in x squared across. We can have x squared equals 1000 divided by all this term in the calculator, which gives us, I'll just tell you exactly what this gives us. Yeah, it gives us 1000 over 3.614. Write down 614, and that's it. And then square root this answer. This should give us a nice value of 16.63. Oh, good. So we're going to assume that this is the values, and again this is plus minus, okay? So plus minus solution because you square root it. Now we're going to put this back into the equation p, and therefore this tells us that the minimum value p, so we go find the min p, would be, okay, so assuming we use if we use a positive value, what happens? Assuming we use a positive value, we're going to get 1000 over this p value. Let's call this x min. So this value is called x min. So we're going to put this in the calculator. Plus x min. So pretty much put this all in the calculator. Okay, I'm not going to write the whole thing out. What does this give us? Well, this should give us exactly, will give us to the nearest meter 120 meters. Cool, not bad. If you chose a negative value, you just get minus 120, which of course you don't want. You want to use the positive value. And finally, let's do part A. Justify by further differentiation that the value p you have is a minimum. Well, that just means we need to differentiate once more. So find dp over dx squared. Okay, once this actually starts working, hence, let's take a second derivative. So we're going to have, where's my pen? So it'd be d2p over dx squared. So differentiate this original equation here once more, dropping the power down. So we're going to have minus 2 drop down will be 2000 x to the negative 3, and this whole constant disappears. So we're left with this, and to show this minimum needs to be positive. And yes, if you plug the 16.63, we're going to basically get 2000 over 16.6 cubed, which obviously with our calculator is positive. Hence, it is a minimum. Hence, the p we use is a minimum value. So p is minimum. That's it, guys. Hope this helps, and I'll catch you guys next time. Ciao for now. Bye.